So, Robert Lempert, Principal Researcher at RAND, Director of the RAND Pardee Center, and President of the Society for Decision Making Under Deep Uncertainty. Thank you for joining us.
My pleasure.
Let's first talk about your field. How would you describe your field?
The formal term for what I do is I do decision support under conditions of deep uncertainty. And the goal is really to use analytic information in decision processes when there's a lot of deep uncertainty inherent in that analytic information.
Okay, thank you. And what are the sorts of methods or techniques that you would count as the notable proposals of your field?
This is at least as we see it, a relatively new field which is coming together. We've got a particular flavor of analysis that we use called robust decision making, which I'm sure we'll talk about a little bit in this conversation. But it's a class of methods which falls under the heading of the decision making under deep uncertainty, and are generally a set of methods that follow this backwards analysis or agree on decisions analysis, which is meant to help groups of people reach consensus on actions, even if they disagree about uncertainties and about objectives. It is the method's built on scenario. I mean, it builds in scenario techniques, and the essence of a scenario, one of the important essences of scenario techniques, is that you represent different worldviews with different scenarios. So without emphasizing probabilities that one is more likely than others. They're basically, none of the scenarios is privileged over the others, and if done properly, they provide buy-in for different groups who see, take ownership of one of the scenarios, even if they don't like another, and that brings them the analysis into the discussion, and then you can start encouraging them to see how the world might look like from another scenario, and that's a standard thing done in qualitative scenario analyses, and we try to build analytics that can speak in the same sort of language,
and that reduces the strategic use of uncertainty.
It makes a lot of the things that people often do less effective.
Okay. We're really interested here to the normative question of how we should go about dealing with deep uncertainty and using it or facing up to it in decision making. So maybe you should say a little bit more about how your field or how this particular method.
Okay. Yeah. So I mean, there's a lot of very creative and great work in trying to come up with sort of the decision rule for conditions under deep uncertainty, and I suppose I'm a little skeptical that there is a single best decision rule for conditions under deep uncertainty, and I think the class of problems that have this sort of uncertainty are ones where ultimately they're problems of social choice with deliberation, and that what you're really trying to do is help people make better informed decisions by bringing the analytics into their deliberations. So in that sense, the normative claim is more process oriented, and that you're trying to help people make decisions where they're not going to be surprised, so that they've scanned the future effectively and with sufficient completeness, so that there aren't things that happen that, had they known about, they would have done something fundamentally different, and scan their options effectively, so that there's not an obvious thing that in retrospect they said, oh God, if we only thought of that, we should have done it, so that the normative approach is to set up a process where people do a really good job exploring their options, really good job exploring the possibilities, and a really good job of considering how options play out against various possibilities according to a variety of different values that people have about outcomes, and come to a choice which is informed by the best science, but has explored this space effectively.
Okay. Sorts of methods you've been describing, would they be standard, well-established methods in your field for a long time, dealing with uncertainties with which we're familiar, or are they specific, for example, to deep uncertainty that we've been talking about?
Yeah, I mean, the field of decision-making under uncertainty, but under risk in the Knightian phrase. I mean, there's very well-developed mathematical tools which people have been developing and using for a long time. And there are a broad class of problems where those are quite appropriate, because we do have high confidence information, either frequentist or subjective information about the probabilities, and so these tools are great to use, and and are easier, more efficient to use than a lot of these decision-making under deep uncertainty tools and methods. What I think is, I mean, the decision-making under deep uncertainty methods, I mean, in some sense, I take a little bit of a neoclassical view in that it's not that these ideas underlying the tools are at all new. It's basically take a plan, stress test it over a wide range of futures, use a scenario language, try to craft an option set that's dominant over a wide range of expectations over the future. So these are not new ideas at all. But what's changed is the underlying technology we have for doing decision analytics has become much more powerful. And I'm old enough so that when I first started playing with computers, a model was a box of cards, and you would bring it to the to the basement in the evening, and they would, you put in a queue, and they would run it overnight, and you'd come back, and you'd discover that you'd made an error on card 536, and you'd have to run it again, and you had this, you got one try a night to run your model, right? And so you worked really hard to get the right model, and you would run it, once, or maybe you would run a probability distribution over it, but you had to specify everything up front and run it, just because the whole process was it was marvelous at the time, but clunky, right? And now you can, I don't want to say trivial, but it's, you can imagine taking complicated models of a system you're interested in and putting it up on Amazon Web and running a million cases, so that you can take, all the policies you can think of and try them out in all the futures you can think of. And then have the computer help you do a search to find either policies you haven't thought of or futures you haven't thought of. And you can do all that, and then you've got this massive database. And the traditional thing is, well, I can't look at a massive database, it's too big, so I'll put a probability distribution over it and project it down into a few numbers, a mean and a variance, or a couple of moments. And so I make sense of it that way. But now you can ask a big database all sorts of questions. I mean, routinely you go onto Google and you say, okay, look at all the websites in the world and tell me the one that'll find me the best place I want to go to dinner, right? And that's not a probabilistic question. Maybe there's some probabilities in the way they come back, but fundamentally it's asking you a question. You're asking it a different question. It's a big sort question. And so similarly, you can put your models up on Amazon Web Server, you can run them over all the futures you and the computer can think of, and then you can ask it something like, okay, separate all the futures into two classes, one where I'm happy with the outcome and one where I'm sad, and tell me the most important differences between them, other than I'm happy and sad. What are the key driver differences, fundamental differences in the type of future where I'm happy and I'm sad? And so we've got this amazing new set of powerful tools to ask different sets of questions of our models and data. And much of the work that I do and our community does is realizing the things that one can now do, and in creating different data sets and asking different questions of it that can inform these questions under deep uncertainty. So the fundamental question of where does our policy go wrong, where might it go wrong, and how might we fix it, you can now ask in different ways.
Using these computational...
Using computational capabilities in the right way, yeah.
Okay, thank you. So let's turn back to the sorts of important, the deep uncertainty decisions we've been talking about. And suppose you're asked for general advice that you could give to policymakers, or you would like to help policymakers make these sorts of decisions the right way. What would you say to them? What would you say to anyone who would like to help them?
Yeah, I mean, the basic message is trying to get people to move to a culture and a decision style where they test their decisions against multiple futures, get an understanding where they might fail, look to see if there are easy ways, what they can do to hedge against those potential failures, and when they put a policy into place, have an understanding of what bets they're making, what they've done to hedge against risk, and the bets that they're leaving on the table. So I mean that's the analytic, the computational ability to do that is really falling into place, and so then it's the big frontiers are in some sense the development and diffusion of these techniques, and you're developing a decision-making culture where that's the expected norm. And go ahead.
Do you generally get positive feedback from any policymakers with whom you've used these sorts of techniques, or what sort of feedback?
Yeah, I mean, we tend to work with self-identified people who have self-identified leaders, people who have big problems that they're pretty convinced that they're not going to get at with other methods, and so yes, we get positive reactions. It's a nuanced thing. I mean, so sometimes there's a lot of people that we work with that they want part of the analysis. They kind of see the grand vision, but they're not ready for the whole thing. So we'll even get people that we show them the whole song and dance, and they go, we're really now much more invigorated in our determination to do a classic scenario analysis, right? Which is good. So they've gone from their point forecast or their basically a point forecast. Now they're going to do a scenario analysis, in part because they see as a stepping stone perhaps to the full-fledged thing. In other organizations, part of the organization will go through the whole exercise and then figure out how to talk about it with another part of the organization. So we've had some our marquee successes are the Louisiana Master Plan for a Sustainable Coast, which is not many scenarios, so it's sort of RDM light in that case, though a lot of options analysis across those scenarios. And that was a very effective stakeholder process, passed the state legislature unanimously. A lot of public officials saying, we thought this was not going to be a science-informed process, and oh my God, it was. This is great. And work with the Bureau of Reclamation in the U.S. on the Colorado Basin, and then they've picked it up, and they themselves have been doing these methods. Again, not in their full glory, but integrating.
Small steps.
Yeah, small steps, integrating pieces of them, and I think there's a lot of take up with the idea. Okay, yeah, no, you really, and then the World Bank has got a group within it. Which is several groups within it, which use our methods and similar methods. They've got various projects writing guidelines for their lending guidelines for using these sorts of methods. So it's what do they say? I mean, that if you that change happens a lot more slowly than you would like when you start out doing one of these things. But sometimes it does work.
Okay, thanks. I'd like to talk a little bit more about the future now. And so in your view, what do you think the central challenges are going forward, both in terms of application or perhaps even further development of the sorts of tools you...
Yeah, I mean, there's a whole number of potential, important developments in the tools, making them easier to use, getting visualizations, understanding what visualizations resonate with different audiences, the capability for doing, multi-objective, multi-scenario Pareto surfaces is getting pretty close, but it's not quite there. So there's a whole long list of tool improvements. But I think the big frontiers are thinking more about how to connect this into different sorts of discussions. So I'm currently very interested in the idea of how do you use anthropological methods to identify particular features of the communities that you're engaged with. How does one appropriately do the analysis for different groups separately, and then understand how you would bring that together to chart spaces of a potential agreement, potential overlap, those sorts of things. I think connecting it with, say, perhaps more game theoretic understandings of how different components of an organization or different players in a group make strategic use and misuse of uncertainty, and then how one can then organize and pace the way one of these, the iterative framing and unframing of the decision might more effectively move the group forward as opposed to rip it apart. And so a number of how this sort of analytics plays out in decision processes, I think is a rich area.
So just a clarification question to make it. So currently the applications have been just basically with one group of stakeholders. I'm talking about the anthropological element.
Well, no, it's been with multiple, many stakeholders, right. But the understanding of how to best organize the analytics to interact with them has been much more based on instinct. Okay. So you sit down with, say, the convener or some, a small number of case stakeholders and say, what do we do at the next meeting? And not informed by people's judgments, but not by any deeper understanding that you might get out of, say, social science methods. Okay. And so informing those discussions, putting more work into learning about how to form those discussions, sort of commensurate with the amount of work has been done on building tools, seems an exciting frontier. Yeah. And then actually one more exciting frontier is ways to use simplified models or make the model construction process simpler. So we had some talk today in the meeting. When the value of simple models, and when and how to insert simple models, maybe very simple models, say elicit a model on key pieces of the system, so that you can learn something and decide whether it's whether you need a lot more modeling and data in that area, or you can you've covered that sufficiently and can move in some other direction.
Robert Lempert, thank you very much for joining us.
My pleasure.